In today's lesson, we are going to be looking at percentiles and outliers. So in our previous lessons, we have been looking at some measures of central tendency and some measures of spread already. We've looked at mean, median, and mode, which are the central tendency values, and we've looked at range and standard deviation so far for measures of spread. Today, we're going to continue with measures of spread, and we're going to look at percentiles and box and whisker plots. So what are percentiles? Well, percentiles basically divide the data up into 100 intervals that have an equal number of values, right? So percentiles, right, they range from 0 to 100, and they divide the data up so that they contain equal portions or equal amounts of the data values. And the way we usually read percentiles is it's blank percent of all data is less than or equal to a specific data value. So for example, you might be like, okay, what does that mean? Well, for example, a data value is often represented as a percentile, making it easier to compare with other values. So for example, we might say a person's height is in the 80th percentile. Right? So that means that 80% of the population has the same height or less than that individual. Likewise, 20% of the population would have the same height or be taller. So 20% is the same height or taller. 80% has the same height or less. We're talking about the 80th percentile. Right? So again, it's basically saying a certain percentage of all the data is less than or equal to that individual or that value, whatever it happens to be. Right? So we can see how much is, basically we can see where do they fall in the scale of all the data, right? What percentage of data is below, what percentage of the data is above. If there's very little data or percentage above them, then that means that they are near the top, right? They're on the extreme end, right? Same as if there's a high percentage above them, right? Then they're on the other extreme. Just likewise, if we said the 10th percentile, 10% is the same height or less, that means they're on the other extreme. They're on the low end, whereas the 80th might be on the high end. And there's a couple formulas we're going to be dealing with when we're looking at percentile to help us kind of find or see where do certain values fall. One is looking at percentile rank, right? So R, or the rank, is equal to the percentile divided by 100 times n plus 1. P is the percentile, n is the size of the population or the data set, and R is the whole number rank of the data point. And this is essentially referring to a position. So the rank, R value, this is referring to a position. So even though it's called percentile rank, essentially what it's doing is it's going to help us find where a specific value is, right? Or which value represents a specific percentile. So percentile rank is going to help us find a position. If the R is not a whole number, then you round down and find the midpoint. And again, we'll look at an example of what we mean by that. If R is a whole number, then we simply just take that position, take that value. If we're looking at percentiles, if we want to find what percentile a value is in, right, we have P equals 100 times L plus 0.5 E divided by N. P is the percentile again. L is the number of data less than the data point that we're looking at. E is the number of data equal to the data point. And N is the size of the population. So this is going to be a little bit of a different type of calculation because the value we're using, or the values we're replacing the variables with, isn't just a singular number. We have to actually do some counting. But again, we'll be looking at some examples. So, for example, the mean playing times per game for 22 hockey players on a team are given. So these are all times in minutes. We wanted to figure out the 40th percentile. So we want to find out, okay, which value is at the 40th percentile? Which value represents 40% of the players being less than or equal to? right? So in this case, when we're looking for the percentile, we're looking for a value. So in this case, we need to use our percentile rank formula. So R equals the percentile divided by 100 multiplied by the population plus 1, or the number of data points plus 1. So in this case, our percentile is 40. So 40 divided by 100 times, there's 22. So 22 plus 1, or 23. We go through and do this calculation, we get 9.2. So because it's 9.2, we have to round down to 9. We round down to 9. Again, like we said, if it is a whole number, we just take that value or take that location. So this is this is a location. This isn't the value. So we use the percentile rank formula to find the position or the location of the value we want. So this is not the actual value. So you want to keep that in mind. Right? What we need to do though first, similar to when we're kind of using or looking at for the median or something like that, we need to order our data. We need to order the data, otherwise the rank of the position doesn't really matter, right? Because it could be anything. So when we're looking for the rank or the position, we need to order our data. So in this case, if we go through, we look for the 9th position, or because we rounded down. So because we rounded down to 9. So then therefore, we have to find the 9th and 10th position and find the midpoint. Essentially because the rank didn't fall quite exactly on a singular value, means we're somewhere in between the 9th and 10th position, so we find the midpoint. So if we go through, this data is now ordered, so we count through. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our 9th value. This is our 10th value. We want to find the midpoint in between. We want to find what is this value, and that will be our percentile. So in that case, we add our two values up. So 16.4 plus 16.7 divided by 2 equals 16.55. So therefore, the 40th percentile is 16.55. So that means that 40% of the data is less than or equal to 16.55 minutes. Right? So that means 40% of the players played less than or equal to 16.55 minutes. You could then also say that 60% of the players played 16.55 minutes or more. The other formula is we want to now find where does a specific player fall, or where does a specific value fall. So this is where we use the percentile formula. So percentile rank was finding, okay, what values at a certain percentile. Using the percentile formula, the P equals 100 times L plus 0.5 E, all divided by N. That's going to tell us what percentile a specific value is at. So in this case, again, this formula, the P percentile, we don't need to fill in. We know 100 is a part of it. L refers to the number of values less than, right? So we go through our data. We're using the ordered stuff because, again, it needs to be ordered. In this case, we find our values. So because we're looking for 21.7 minutes, we find those values in the table. We will come back to those. We then need to look for L, which is the number of values less than. So all these values here, these are all the values that are less than the data points that we're looking for. So that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We have 17 data points that are less than the value in question. We then add 0.5. So the 0.5 is just part of the equation. It's not specific to this question. You use 0.5 regardless for any calculation when finding the percentile, times E, which is the number of data points equal to what we have, in which case we have 2. Even if we had 1 data point, right, you could still put 1 down. If you had none, you'd put 0. So it all depends on what the value is we're trying to find the percentile for. And we divide by n, which in this case is 22, because there are 22 players, or 22 values. We go through, we do our calculation, and we should get approximately 81.8. Now we can round if we need to, but therefore what this is telling us, what this percentile means, is that 82% of players played less than or equal to 21.7 minutes. So that means if you played 21.7 minutes, you were on the higher end of the spectrum, right, in terms of like playing time. So you'd be on the higher end because 82% of players played equal to or less than. And usually we kind of refer to the idea of, okay, it being less than that value. So 82% of the players played less than that value. So again, you're on the high end, and it basically allows you to see where that data value or that data point is located in our overall data. So it lets us know, are we on the high end? Are we on the low end? Are we in the middle? Whatnot. So that was looking at percentiles. Now, another thing that we can look at, another kind of measure of spread, or in this case, a visualization of a measure of spread, is box and whisker plots. And the reason we're looking at them alongside percentiles is because the key points of a box and whisker plot are related to percentiles, or they basically are specific percentiles. So in our box and whisker plot, we look at quartiles. And the quartiles we're looking at are Q1, Q2, and Q3. And they are representing specific percentiles. Right? So essentially what quartiles are, they are basically data points or values that divide our data into 4 equal parts. So they divide the data into 4 equal parts, similar to what percentiles do. Percentiles divide data up into 100 equal parts. Quartiles are dividing the data up into 4 equal parts. And each quartile is represented or can be represented by a specific percentile. Q1 is the 25th percentile, Q2 is the 50th percentile, and Q3 is the 75th percentile. Now we've already calculated Q2 before because Q2 is essentially the median of the overall data set. If it's the 50th percentile, it means 50% of the data is above, 50% of the data is below. That is our median. That's our middle value. We could characterize Q1 as basically saying the median of the first half. So if the first half of data is 50% of it, then the middle would divide it into equal 25% parts, or the 25th percentile. On the upper end, Q3, the median of the second half of data, right? So if we're looking at the upper half, 50% is on the upper half. We find the midpoint or the middle value to divide our data into two. That would be the 75th percentile. So we can use percentiles to find these different values of our box plot. And it just shows us how the data is spread out. Right? So we can see an example here. We have our lower extreme. With this part would actually be called our whisker. So we have our whiskers on either end. And we have our box in the middle. So that's how it gets the name, a box and whisker plot. Right? You can think of a little cat. With its whiskers. Right? So that's our box and whisker plot. Lower extreme, or basically the minimum, upper extreme, the maximum, our Q1, our Q2, and our Q3 all form, or all are used to form our box. With that box and whisker plot and with those quartiles, there is another measure that we can calculate, which is the interquartile range. And the interquartile range is the difference between the point that is higher than 25% of the data, or basically the 25th percentile, and the point that is higher than 75% of the data, or the 75th percentile. So essentially, if you want to find the IQR, interquartile range, you just basically take your Q3 and you minus your Q1 from it. So it's looking at the range of data within this section here. So basically you're finding what is the range of the middle half of the data points. Right? So this here, that's your IQR. From here to here, that range is your IQR. And this box is 50% of your data. So it's similar to kind of like the normal distribution that we talked about previously. It might be more important to see how does the middle 50% look. Right? The ends of our data, the two opposite ends are most likely extremes, so we might not be too concerned about them. We want to see, okay, what does the middle look like? What does that average, that central value kind of look like? Right? Where is that middle 50%? What does that look like? With these percentiles and the IQR, we can use that to determine statistically if we have any outliers. So we can statistically determine if values are outliers by using the following formula. So if any values lie less than Q1 minus 1.5 times the IQR. So you take that IQR, that interquartile range, you multiply it by 1.5, and you subtract it from your Q1 value. If it's less, or if you have any values that are less than that, they're considered outliers statistically. Same as if you have anything greater than Q3 plus 1.5 times the IQR, then you have values that are outliers on the extreme end, on the upper end. So we can use the IQR to basically determine, are any of our points statistically outliers? Could we remove them from our data because we're saying they don't fit the trend, right? They don't kind of match what's going on. Maybe there's some bias that occurred. Maybe there's some errors in the calculations or the data collection, or maybe it's just kind of one of those odd cases that doesn't fit the pattern. So below, or we have a table below that lists the heights of the 20 girls who tried out for the basketball team, right? A hypothetical basketball team, right? We have our frequency, we have our cumulative frequency. We want to find the median. We want to find the 50th percentile. Now, we could go through and find the median similar to what we had done before, right? Find the middle value, but we're going to focus on using the percentile formula. So in this case, because it's the 50th percentile, we want to find the rank or the position of the 50th percentile. So we're going to use our formula P divided by 100 times n plus 1. So 50 divided by 100 times 20 plus 1, we get 10.5. So that means we round down to 10. And we find the average or the midpoint. The average of 10th and the 11th number. Looking at a cumulative frequency, we can use this table to help us figure out where the value or where the position would be. Right? So here we have 1, then the next one is anything that's from 2, 3, and 4. Then the next interval is 5, 6, 7, 8. Oh, so it's not in there. The next one then is 9, 10, 11, and 12. So it is going to fall within this interval. Right, so the 10th and the 11th are going to fall within here. Similar to when we looked at intervals, we're going to use the midpoint as our estimation or value. So the midpoint would be 172.5. So because the 10th and 11th fall within there, we have to add that twice. Add those two values, right? We're estimating that that's what the values are. Divide by 2. We get 172.5 is our 50th percentile or our median. So our median for this data is set 172.5. We want to do the same thing, finding the first quartile or the 25th percentile and the third quartile, the 75th percentile, and then use those together to find our IQR. So for the first percentile, 25, or the 25th percentile, the first quartile, 25th percentile, so same formula, 25 divided by 100 times 20 plus 1 equals 5.25. That tells us we have to round down to 5. And we have to take, therefore, the average of the 5th and the 6th data points. So the 5th and the 6th data points, if we look at this, they do fall both within this category, this interval, the 165 to 175. So those two fall under that category. Right? So we could add the two numbers, two midpoints together, divide by 2. It ends up being the same thing. So therefore, our value is 167.5. That's our first quartile, our 25th percentile. So at 167.5 centimeters, 25% of the data is less than or equal to that value. Our third quartile, again, same thing. It's the 75th percentile, so 75 divided by 100 times 20 plus 1 equals 15.75. This means we have to round down. Right? It's an odd number, so even though technically we would round up, we still have to round down to 15, and therefore we take the average of the 15th and the 16th data point. So 15th and 16th, in this case, it is two different ones. The 15th is in this interval because we see the cumulative frequency is 15. So the 15th value is the last one in this interval. The 16th is then in the next one. So this one's a little bit different from what we've done. We do have to add these values. So 172.5 plus 177.5 divided by 2, and we get 175. So therefore, the 75th percentile of this data set is 175. To then find our IQR, our interquartile range, we would take our Q3 minus our Q1, which we found. So 175 minus 167.5, which equals 7.5. So that means that our IQR, that middle 50%, has a range of 7.5 centimeters. So again, you can kind of use that context to determine whether that's a high range or a low range. If we're talking 7.3 centimeters in terms of height, I'd say that's relatively, that's a fairly decent amount. We're maybe looking at about 3 inches, right? 3 inches of height difference. Next, we want to take those values and create a box and whisker plot. So in order to do that, we need to have a minimum, a maximum, our Q1, our Q2, and our Q3. So our Q1 and our Q2 and our Q3 we've already found, right? Our Q2 was our median that we found initially, 172.5. Our Q1, 167.5. Our Q3, 175. Our maximum value, or our minimum value, we're going to say the minimum height, looking at our range, was 155. Our maximum height, or our possible highest value, is 195. The upper end of our intervals. So the way the box and whisker plot works, the way we draw it, is our box is formed by our Q1, Q2, and Q3. The max and min, again, we said form our whiskers. So my Q1, 167.5, so we'll say we'll put a mark here, that's our Q1. Our Q2 is 172.5, so about here. And our Q3 is 175. So those 3 lines form a box. We then draw whiskers out to our highest value and our lowest value. So we're going to put 2 markers there, and we're going to draw whiskers out to those high and low ends. So one out to 195, one out to 155. Right? So this was our max, and this was our min. And that's our box and whisker plot. So that shows us how the data is spread out. Right? We see that middle 50% is close together, but we do have some extreme values that would cause, you could say the data isn't very, the middle 50% is close together, but overall the data is very spread out. We can see kind of a range of values. We could calculate the range if we wanted to, not just the IQR, right? The range, the highest minus the lowest. We could look at that middle 50% as well. And we calculate that IQR previously of 7.5. So the middle 50% is very close together by comparison to all the data. What we can do as well is we can check to see if there are any outliers. Right? So there's 2 scenarios for the outliers. Q1 minus 1.5 times the IQR, or in this case, 167.5 minus 1.5 times 7.5. And in this case, we end up with 156.25. And on the other end, our Q3 plus 1.5 times the IQR. So we have 175 plus 1.5 times 7.5. We get 186.25. So could we have any data that is above or below those 2 values? Right? If we look at our data, we do. Right? We have data, this value here, this is above, or this is below. And we have this value here, which is above. So those 2 values are statistically outliers. So what we can do then is now we can go through and we can calculate, or we can recreate our box and whisker plot to accurately show the outliers. And then when you use technology to create these box and whisker plots, some software will create or determine these outliers for us. So we can say that the lower one, the 155, that low end, that is an outlier. We're still going to put a dot there. And same with the 190 to 195, we're still going to put a dot there. Well, we're still going to go through, do our Q1, which was the 167.5, our Q2, which was 172.5, and then 175. We're still going to go through and create our box there. So our Q1, our Q2, our Q3. That doesn't change. What does change now is our new max and min. What's our new highest and lowest value? Well, if we look, we can see the new low value is in that 160 to 165. So we can put a mark at 160, our potential low value. And our new high value is possibly 185, right? Because again, there's a value within that category. Technically, if we wanted to go back and highlight anything that would be in potentially in that interval as well, the 185 to 190 would be considered an outlier. And then finally, what we can do is we can join our whiskers to our new max and min. So this would now be our new max, this would be our new min. Right, the other two are considered outliers. So even though they're above and below, we don't consider them our max and min because they're outliers. They don't fit our data. So that's how we can use these measures of spread, the percentiles, the interquartile range, the quartiles, to find different data points, allow us to characterize different data points in terms of where they fall, how much data falls above and below, and also to create box and whisker plots, which allow us to visualize the spread of the data, how the data is spread out, and also statistically calculate whether we have any outliers or not.